Welcome back to the online sessions on MWT. And today what we do is we try to complete the multi-cavity Klystron amplifier. Okay, so here we discuss about the construction and the operation of the multi-cavity Klystron amplifier. In the previous class, we discussed about a Klystron tube as an oscillator. Now we'll see Klystron tube as an amplifier. Okay, so if you have more than one cavity, then we can normally use that as a amplifier. So in the last class, we just introduced that it is going to be the basic practical Klystron multi cavity amplifier, right, where all these three are going to be the three cavities. So because of these cavities, what is going to happen now, the number of bunches which is normally going to get formed are normally going to increase. So because of more number of formation of bunches, the amplitude of the signal is normally going to get raised. Okay, now what is the basic schematic diagram of this two cavity Klystron amplifier? So the two cavity Klystron amplifier basic diagram is going to be something like this, where initially you're going to have Klystron tube. For a Klystron tube, we normally going to have a cathode. Cathode is going to emit the electrons, and this cathode is normally applied with a beam voltage, maximum DC voltage of 300 volts DC. And here we normally going to put some grids in order to guide the electrons towards the buncher cavity. And the cavity where we apply the input is going to be called as buncher cavity. And the cavity at which we normally get the output is normally going to be called as a catcher cavity. So buncher cavity is known as the input cavity, and catcher cavity is known as the output cavity. Okay, so it is going to be the output cavity. So catcher cavity is known as the output cavity. Buncher cavity is known as the microwave input cavity. So now what happens here, and the space between center of the cavity of buncher cavity and center of the catcher cavity is nothing but known as the drift space. So in the previous class, we discussed about a single cavity reentrant Klystron oscillator. Now here we got a two cavity Klystron oscillator. Right. So now in this, what happens now? The input is basically applied from the buncher cavity, which is going to be AC in nature. Now these electrons, which are DC electrons, because of the DC supply, are normally going to up to the puncture cavity. The velocity of the electrons is going to be normal as it is supplied by the cathode of this particular uh, electron gun. Then now these electrons, once they reach into the buncher cavity gap, what will happen now? Now these electrons are normally going to excite more amount of energy. So when the input is positive going half cycle, then what happens? These electrons are going to attain more energy. When the input of signal is going to, when the input of the signal is going to be negative, because input is going to be varying in oscillation fashion, no? So therefore, when the input is negative, the electrons are deaccelerated. When the input is going to be positive, electrons are going to be more accelerated. That means, and when the input is going to be at zero, that means the electron is normally going to travel with the velocity of the electron before the puncture cavity. So therefore, similar to the previous case, we normally going to consider a reference electron, early electron, and a late electron. So with that concept, what we can have now, so three set of electrons are normally going to experience three set of velocities. So thereby we can just say that some bunch of electrons are going to be faster, some other bunch of electrons are going to be slower. So by this, what happens now, because of this variation in the speed of or velocity of this electrons coming from cathode, that means here what is happening actually, the electrons coming from the cathode are simply modulated, and because of this modulation, what happens, more number of bunches are going to take place. As the number of bunches are going to take place, forming of these bunches is due to the velocity modulation. So because of this velocity modulation, what happens, many bunches are normally going to get formed, and intermediate to this particular buncher and catcher cavity, the amplitude of the signal is normally going to increase like this. As the electron, as the what is this beam electron is normally traveling after modulation through the drift space, are normally going to get amplified because of the velocity modulation. Okay, so then after this, what happens inside this? The current modulation is also inside the catcher cavity. Current modulation is going to take place. That means increase in the amplitude of this current of the signal is going to be called as current modulation. So velocity modulation and current modulation are going to take place in the two cavity klystron amplifier. Whereas in the case of single cavity reflex klystron oscillator, velocity modulation is the only one which is going to take place. Okay. Now let's go ahead further. What is the basic principle of operation of this multi-cavity? Now here we are dealing with the two cavity. We can have multiple cavities. Okay. In the previous slide, if you see, this is of three cavities. Okay. But for the explanation sake, we can explain with a two cavity. Now we can just go and increase the number of cavities if at all you wanted to increase the amplitude of the signal. If at all you want to increase gain of the entire circuit, you have to go on increase the number of cavities. Okay. So let us look into the operation now. So the principle of operation basically depends on the velocity modulation and the current modulation, and hence the tube is going to be velocity and current modulated tube. So here the high velocity electron beam, which is because of the DC voltage, is generated by an electron gun. Okay, and sent down along the gas tube through the input cavity known as buncher cavity, and the drift space obviously intermediate to the buncher cavity and the catcher cavity is going to be drift space, and an output cavity to a collector electrode anode. Okay, so that means finally it will be reaching to the output cavity. So the anode is always kept positive. The anode is always kept positive to receive the electrons. So when the anode is kept positive, the electrons are going to get accelerated towards this particular cavity. Okay, so while the output is taken from the tube via the resonant cavities with the aid of the coupling loops. So using coupling loops, we normally going to collect the output in a systematic manner. So here, while we normally going to collect the output, there should not be any loss in the signal power. Like that, the coupling has to be perfectly aligned. Coupling has to be there compulsorily. Okay. So next, let us look into the basic operation of this multi-cavity amplifier. So the two cavity klystron is a microwave frequency amplifier. That means, what is this meaning of microwave frequency amplifier? This two cavity klystron is going to amplify the signals at microwave frequencies, which operates on the principle of velocity and the current modulation. So all electrons injected from cathode arrive at the first cavity with a uniform velocity. Up to first cavity, the electrons will be coming with a uniform velocity, because there is no modulation in the velocity of the electron coming from the electron gun. Now what happens now? These electrons has to pass to the first cavity where we apply the input signal, so known as buncher cavity. These electrons should pass through the buncher cavity where we apply the input signal. So those electrons pass in the first cavity at zeros of the gap voltage. What is the meaning of zeros of gap voltage? That is the signal voltage. So signal is going to vary sinusoidally. When the signal is varying, say, sinusoidally, what will happen now? Every signal is going to have a DC voltage, maximum voltage, minimum voltage, and intermediate values. Okay, so that means you should remember the sine wave compulsorily here. Sine wave is constructed starting from DC voltage, going towards peak and coming towards zero, once again coming to maximum negative, once again going to negative, going to zero. Like that, the wave is normally going to get repeated. Yes or no? So therefore, those electrons passing the first cavity gap at zeros of the gap voltage pass with their velocity unchanged. That means there is no modulation taken place. There is no modulation taken place for the beam electrons coming from the electron gun at the zero signal voltages. Okay, so there is what the first point which we can write. Then second point, what we can write: the electrons, those passing during the positive half cycles of the gap voltage or input voltage, undergo an increase in velocity. Positive means what? The electrons are got accelerated. It means the electrons are going to attain more energy. So those passing through the negative swings of the gap voltage undergo a decrease in velocity. On the other hand, what happens? The input signal is going to take the negative cycle also. So when the negative cycle of the input comes, then the gap voltage undergo a decrease in the velocity. The electron beam velocity is normally going to decrease. Now, due to these changes, continuous changes, changes in the velocity of the electrons coming from electron gun. Because of this result, as a result, what we can have, the electrons gradually bunch together as they travel down the drift space. In the drift space, the electrons are going to form like bunches continuously. So the variation in electron velocity in the drift space is known as the velocity modulation. So what is velocity modulation? The variation in the electron velocity in the drift space is known as the velocity modulation. Okay. The next one is going to be these electrons, the electron density in the second cavity gap varies cyclically with time. So obviously the bunches are varying cyclically with respect to time. Obviously the electron density inside the second cavity gap is also going to vary cyclically with respect to time. The electron beam contains the AC component. Why it is AC component? Because the bunches which are forming in the drift space are forming like a forming in a AC signal fashion and is said to be current modulated. That means here the electron beam contains AC components and they are said to be called as current modulated in the buncher in the catcher cavity. Sorry. So the maximum bunching should occur approximately midway between the second cavity grid during its retarding phase. So the maximum bunching is going to take place exactly midway between the buncher cavity and the catcher cavity. Okay, so that is what the basic concept which we can just keep in mind. So the kinetic energy is now transferred from the electrons to the RF field of the second cavity, to the RF field in the second cavity. That means here what happens, initially the electrons are moving with the kinetic energy. The kinetic energy is simply converted into a RF field signal in the buncher cavity. So the electrons emerging from the second cavity have reduced velocity and are collected by the collector. So the electrons which will be coming from the second cavity are little bit reduced velocity, so that we normally going to collect the velocities, so that we can normally collect the RF signal from the output of the collector. So from the output of the collector using the output uh, catching cables, we normally going to catch the signals, or coupling cables, using appropriate coupling cables, we normally going to couple the output signal to the load. Okay. Now practical cross section. Now if you see the cross section of the two cavity klystron, it simply looks like this. It's going to have a cathode. It's going to have electron gun. This electron gun inside is going to have a cathode. Cathode is going to emit the electrons. And the first guy is going to be grid one, which is going to be anode, so that the electrons are going to get guided and drifted and guided towards the cavities. Now inside the cavities, once again, we normally going to have grid 2 and grid 3. Inside cavity 2, you're going to have grid 4 and grid 5. Like that, as the number of cavities increases, the number of grids are also going to increase. Now, what is the purpose of grid? The purpose of grid is to guide the electron beam in a particular direction. Okay. So we apply normal input to the we apply input normally to the RF input is applied from buncher cavity. So this is known as buncher cavity, and output is normally collected from the RF output is collected from the catcher cavity. Okay. So now what is that which is happening now? Negative potential is applied to the cathode. Obviously the positive one is simply going onto this side. Okay. The next one is this space is known as the drift space, the space between the gaps of the catcher and the buncher cavity is known as the drift space. Okay. So like this, we normally this is normally grounded, and that means these two, that means these cavities are also going to be connected to ground. So this is what the basic cross-sectional diagram of a multi-cavity Klystron oscillator or two-cavity Klystron oscillator. Okay. So what is finally the operation that it is actually doing now? The input buncher cavity is excited by the RF signal, the which has to be amplified, which will produce an alternating voltage of signal frequency across the gap A. So this voltage generated at gap A is responsible to produce bunching of electrons or velocity modulation of the electron beam. So because of this velocity modulation, what happens? The amplitude of the signal is normally going to change or increase in the drift space. So thereby we normally going to get a more signal at the output, and that output is collected from the catcher cavity. Okay. So this is what regarding the operation of the multi-cavity klystron amplifier. Okay. So this is what regarding the basic operations of the Klystron tube oscillator and a reflex Klystron tube oscillator and a Klystron amplifier. In the next class, what we'll do is we'll try to discuss about the magnetron basic operation. After magnetron basic operation, we'll try to go with some of the underlying basic relationships in the case of the Klystron amplifier and the magnetron. Okay. So thank you very much for the today's session.